for 2, base alpha. 100. Okay, I'll buy that. What's the machine object code? Nothing. Okay, what's the address of the third line?
103.
3.
It's a 1.
103.
100.
Yes.
You
X,
liar.
of course, is not 100.
Base
What
doesn't
is?
do anything.
That's 103.
Okay, 10. What is in decimal?
They're not 100.
Oh.
256. Yes. Okay, just a side note. All right, plus LDB pound sign alpha. Can we do that? Sure. But we have to get the addresses before we can, so let's continue with the addresses. All right, the line with the STL buff. 104. 104. Good. And the next line with the div.
7.
107. Okay, and the next line with the STX. 10A. Nobody's going to put 110, right? Okay. And then STA alpha. STA alpha. I don't hear you guys.
1OD.
10D. Okay, I'll buy that. The last instruction there.
110.
110. Okay. And data. What's the address of data? 113. Okay. And the address of buff.
2113.
The address of buff. 116. Okay. And the address of alpha.
2.
Address of alpha. 2116. Is that right?
Yes.
Okay, and the last one. 2119. Okay, cool. Now then, machine code. The first line, none. The second line, none. The third line, okay, LDB, I have a little cheat sheet here, which I will provide for you guys. And the opcode is 68. It's 68, so we have six, 8, and now what? Plus LDB pound sign alpha. What? Like that?
Yeah.
It costs you got 0.
Well, what's the problem?
Get rid of this.
Only 6 bytes.
6 bits.
Only 6 bytes in format 3. It's the first 6. The last 2 digits here are always 0. So you take the first 6 bits, this is your opcode. Okay. Okay, now what?
0, 1.
Is that what we want?
Yes.
Okay.
0, 0.
Base or PC?
None.
Neither one. Why?
Format 4.
Because it's got a plus in front of it, it's format 4. Questions about this, anybody? It's old hat now, I hope. But again, I was surprised by some of the comments. Okay. So that goes there, that goes there, which gives me 6, 9, 1. Now what's the rest of it?
0, 2, 1, 6.
Does everybody see where this came from? So you have a 5-digit address there, it's 20 bits. Familiar? Are we okay? All right. So quickly then, STL buff. STL buff. Okay. So ST something or another. STL is 1, 4. STL is 1, 4 in hex. That's the opcode. So what do you want me to write?
0, 0, 1.
Okay. And now what?
1,
1, 0.
PC value. PC.
What's the next 3?
0, 1, 0.
Is that what everybody got?
Yes.
Okay. Well, how do you know it's PC relative?
So you don't need to use base. It's not-
Okay, well, it's before the base, and so you can't use base here. You can't do backwards from the base register. So base is off the table without even calculating the displacement. Okay, what's the displacement? Somebody tell me the number. 3 hex digits, what is it? 1 OF?
That's right. 0, 0.
That sounds too big. What's the displacement? Somebody, you gotta know.
F plus 3.
Okay, so this isn't redundant and a waste of time then, is it?
0, 0.
Somebody give me the 3-digit displacement in hex.
0, 0, F.
0, 0 F. So we now have 1, 7, 2, 0, 0 F. Okay, let's check it. Shall we check it? How did we get that number? Okay, STL buff. So the formula is destination minus source plus 3. So the destination, what we're going to go to and read is buff. And the address of buff is 116. I'm leaving off the leading zeros here. And the source, STL buff is at 104. So plus 3 is 107, right? Okay, so we got to subtract, we have to borrow. What do we get? F. Yep. Does everybody see how to do that? Okay. Div data. So moving on to the next one. Div data. Got that for me. give data. Alright, so div, the instruction is two, four. 2, 4. Now how is that 2, 4? It looks like 2, 1, doesn't it? The 2 zeros are missing, right? We don't include those because they're always 0. So that's 2, 4. Okay, now give data. Okay. Try PC relative first to see if it works. And if it doesn't, then try base. That's the general heuristic you want to use. Okay, so we've got N, I, X, B, P, E. Well, this is div data, so it's not indirect nor immediate, and then no X. What's up in the air now is it going to be PC or base relative? So let's calculate. PC relative, destination minus source plus 3. Data, the address is 113 minus the source. And what's the source? 108.
A.
10A, 107 plus 3. Okay. Well, what is 9? Seems about right. So, PC works, forget base. We have 2, 7, 2, 0, 0, 9. Questions? Are we good? Okay. Now we have STA alpha. No, STX beta. Just smearing ink around the machine. STX beta. Okay, so STX is 10, 10, STX, 10. And then we have NIX, BPE. Okay, this is STX beta. So what are N and I set to? 1, 1. Okay. So let's change this instruction just for fun. What would it look like if I want to set the end bit? If I have to set the end bit. If I want this. At. Okay, let's do that. Okay. X. You can't do at beta comma X. That you can't. Not allowed. Okay. Base or PC relative. So try PC relative first. Destination minus source plus 3. So where are we going? Where are we going to read? Beta 2119. Minus source plus 3. 10D. Okay. D is 13, so we can't do 9 minus 13. We have to do this. We borrowed 16 and we had 9. And that's 25 minus 13 yes? 0 minus 0, 1 minus 1, 2 minus 0 is 2. Okay, we have 2, 0, 0, C. Is that okay? What's the matter with it? It's too big. Oh, how's it too big?
Has to be in 3 bits.
It has to be 3 digits, 12 bits. That's the format. Will that number fit in 3 hex digits? No, it won't. Now, just a different question, but the same vein here. Suppose we have a subtraction and we end up with 8, 1, 3. We're reading the storage allocation section. There's a label at the bottom, and that is the offset. Does that one fit?
That's not
What's that?
right.
No. Why doesn't it fit? It's negative. How do you know it's negative? It starts with a 1. Well, first of all, you only have 3 digits. You got 8, 1, 3. And PC relative is 2's complement. They're 2's complement numbers. So the range of numbers that are positive are 0 up to 7FF. That's the largest forward displacement you can have. And 813 is too big.